Okay, welcome to our next lesson again on gradients. We are still finding the gradients of functions when we know what x is. Now, in the previous video, I explained that when you have curves, like for example, this one here, the one that I'm just showing you, when you have a curve like this, what's happening is that the gradient keeps changing, the steepness keeps changing. And the way to visualize how steep the curve is at any particular point is to draw a tangent passing through that point. For example, at this point that I'm pointing at, the gradient of this curve seems to be positive because the tangent is rising up like that from left to right. It's positive. However, when you get to this point here, you can see that the line here, if I draw the gradient is a flat line that is horizontal. It means that the steepness here is 0. The gradient is 0. So it's changed from positive to 0. Now, somewhere here, you can see that the gradient is going to be positive because the line is rising up from left to right. So what the gradient is in a curve will always depend on what x value is. It will always depend on what point you're talking about. So here, x is different. X is going to be there for that. And for this one, x is going to be here. Okay? And for this point here, x is going to be here. So constantly is going to be dependent on what x is. And that's why you see that in these functions, they will always tell you what x is. They'll always tell you which point in the curve you need to work. Okay, so I'm just going to go back again to one example, and then I would like you to pause the video and do the rest. Okay, so if I pick question 1 for you, step number 1 is to differentiate. So I've got dy dx. Right, so starting with this, I got 3 times by 2, which is going to be 6, and then the 3 becomes 2 as a power. The power goes down. Then I'm going to do 2 times 4, which is going to be minus 8 because you have minus in front, and I'm going to have x. Okay, numbers like this normally disappear. So what I'm having here is the gradient function of this particular function, y equals that. Now, I want to find exactly what the gradient is, what dy dx is when x is at negative 1. Okay, now all I now need to do is to sub that one in. Right, so when x is equals to negative 1, then dy dx now can have an exact value. So have 6 times by negative 1 squared. Okay, this bracket means you times it. Then we minus 8 times by negative 1. So where x is, all you need to do is to put negative 1. Right, so doing the indices first, don't do 6 times negative 1 before squaring. You've got to do the indices first. Remember BIDMAS. So negative 1 times by itself is going to be 1, and 1 times 6 is 6. And then coming here, we open the bracket first. So 8 times negative 1 is negative 8. So minus 8 becomes plus 8. So the answer to that is going to be equals to 14. Okay. So all you need to do is basically subbing in. If I pick this other value here, if I pick up this other value, then dy dx is going to be equals to 6 times x squared. So 6 times by x squared, x is 2/3, squaring that, minus 8 times by x, so it's 2/3. Okay. Now simplifying that, first you go to times this by itself. So I've got 6 times by 4/9, because 2 times 2 at the top is 4, 3 times 3 is 9. Then subtracting. Now, this 8 here is a whole number times by a fraction. Remember, you times the top numbers. So you do 8 times 2, all divided by 3. Okay. Now, once you've done that, then you can open the bracket to this. You can do 6 times 4, which is going to be 24, all divided by 9. Then we're taking away what? 16 over 3. Now, once you get to this stage, what you could do is to change the bottom numbers to the same. So I've got 24 over 9. Now, this 3 here, I can make it a 9 by timesing it by 3. But if I times this by 3, I need to times the top one by 3 as well. So I'm going to have 48 there. Now, once I've got this one now, then I can just subtract the top one. So I'm going to have negative 24, all divided by 9. And that's the answer for you. Okay? So I would like you to pause the video now and try question H, I, J. Pause the video, try question H, I, and J. Okay, hope you tried that. Now what we're going to do now, I'm just going to do question, I'm going to do question I for you. I'm going to do question I for you. Now, if you're struggling with fractions, you're gonna need to look at some of my videos on fractions to help you out if you're struggling with those fractions. Right, so try question I. We're going to have differentiate first. I've got dy dx is going to be equals 3 times by 2 is 6 over 3, and then the power will go down. Then here I'm going to do 2 times by 9 over 2, so that's going to be 18 over 2 x squared, okay, plus x. So I've differentiated it now plus 1. Remember, when you're differentiating, x here becomes 1. X always becomes 1 if you differentiate. We've spoken about that a long time. But now we want to find what dy dx is when x, for example, is 1. But let me leave that alone. Let me just do x equals -2. So all we need to do now, when x is -2, I'm just going to sub in. But before that, you can simplify. 6 divided by 3 is 2. So I've got 2. X squared is going to be -2 squared. Close the bracket. Then 18 divided by 2 is basically 9. And then the x squared is going to be -2 squared. So it's going to be -2 squared plus 1. And then all you now need to do is to simplify. Do the indices first. So that's -2 times by itself is going to be 4. And 4 times 2 is going to be 8. Here, do this ones first. -2 squared is 4. 4 times 9 is going to be 36. And then you add 1 there. Okay, as simple as that. Right, so 8 plus 1 is 9. And 9 take away 36 is going to be -27. Okay. So we got 8 plus 1. You have to do add first. So 8 plus 1 is 9. And 9 take away 36 is going to be -27. So that's how to do these kind of questions. Now, when it comes to question J, expand the bracket as you do quadratics. Expand the bracket, then you just sub this. Now, when it gets to question H, remember, you have to bring this one up. And when you bring it up, it becomes negative. So we're gonna have this. We're gonna have 4x minus x to the power -2. Remember, this one here doesn't really matter because it's gonna be 1 times by this. So I could write it here, or I can just ignore it. So before you start, you're gonna write it in this form. So 4x minus x to the power -2. These 2 at the bottom here, if you bring the x up, it becomes -2. Then you differentiate as you've been differentiating, then you just sub in. Okay? So I hope that is clear. So if you just want to use these answers here to mark your work, so pause the video and just use these answers quickly to mark your work. Okay, hope you've done well on that. So that's going to be the end of our session on this area.